Hi, my name's Lee Hunter and I'm the VP of Operations for the Queen's Space Engineering team. Qset entered its first Mars rover in the 2014 URC competition. The team learned a lot from this experience and have used that to guide the redesign of several subsystems for this year's rover. The rover is well on its way to being competition ready. This year on Qset we have three technical sub-teams. The mechanical sub-team, which focuses on the chassis, suspension, drivetrain, and robotic arm. The electrical sub-team, which focuses on power, communications, and software. And the science sub-team, which focuses on geology and science experiments for the sample retrieval challenge. The rover, including the drive system and robotic arm, are currently functional. We've begun testing these systems and are making improvements in the tuning of the suspension and the wiring layout. Meanwhile, components for specific competition tasks are currently being programmed and tested. These include the pH probe, soil humidity sensor, and the GPS module. Our final arm mount is currently being machined, and the camera mounts and protective coverings will be done in the next 2 weeks. The last pieces of hardware left to build are the bucket for the arm, a soil containment apparatus, and the baskets to hold tools during the astronaut assistance task. We're testing indoors until the snow melts and it begins to dry up outside, at which point we'll move to a local park and sports fields at West Campus where we can simulate tasks for the competition and validate the range of our communication system. This year, for the first time, we've used CNC machining on the suspension and drivetrain components. This has greatly improved the quality of these components and decreased the amount of time in the shop over previous rovers that we've built. We're using this aluminum extrusion T-slot material. It provides an extremely high strength to weight ratio, and it also makes it quite flexible when installing components. We opted to use some low pressure balloon tires. Last year we used a 3D printed wheel. We found this worked well in the softer soil, but in the harder soil it just wasn't enough, and over rocks it was just not durable enough for what we're doing. It also caused a lot of low end vibrations. We have a direct connect to our motors this year through our CNC machined hubs. This does expose them to the risk of damage due to rocks, so we've designed this protective shroud. This year we decided to use a double A-arm suspension again with the pneumatic shocks. We used the same sort of setup last year. It worked really well for us, provided us a lot of flexibility over rough terrain, and it was just really durable overall. The robotic arm is a 6 degree of freedom articulated arm. It uses linear actuators on the second and third joints to provide powerful, smooth operation. The end effector is 3D printed. It's based on an open source design, and the fingers are under actuated, which allows them to grip and hold on to valves and objects. The 3 fingers will also ensure that the hand doesn't slip off of the valves during the equipment servicing task.
On the electrical side, our rover is powered by 2 of these 5,000 mAh lithium polymer batteries. These will happily provide over 100 amps, which is why we have a system of fuses, a breaker, and a switch on the rover to protect it. This will soon be replaced by a proper big red button e-stop. Onboard processing is handled by 2 BeagleBone Blacks. Compared to using a separate computer or microcontroller, this has removed dependencies from our code and made it more modular. These custom-built capes provide all the logic levels and outputs that we need. At the same time, the built-in real-time units still let us have fast control, including use of motor encoders. The driver's interface provides a modular view of camera feeds, robot arm configuration, and GPS information when they're most needed. A joystick controls either the motors or the arm using inverse kinematics. I have 3 priorities for between now and competition. First, wiring anything that hasn't been already mounted on the rover. Second, electrical connections. The team has had problems with loose connections in the past, so this year it's a big priority to make sure that everything is securely crimped, tied, and wrapped. And third, the driver experience. We want it as easy and seamless as possible for the driver to control the rover in competition. That's why we've been working with feedback from last year's driver to optimize their interface, and we'll be merging these changes in our code soon.
The whole team has been working hard since last summer to bring a better, more reliable rover to competition. After our 13th place finish at URC 2014, we're determined to place the top 10 this year. We're confident that our design is on track to achieve this goal.